Today we're going to talk about identifying quadrilaterals. Here are some quadrilaterals and the definitions of the ones we will be talking about. These are the ones we are going to be focusing on throughout the lesson. The first, when this says general quadrilateral, this is no quadrilateral specifically. This is just a term to describe any polygon that has 4 sides and 4 angles. A trapezoid is a type of quadrilateral with exactly one pair of parallel sides. So if you notice here, just as a review, parallel lines look like this. Now you'll notice the other 2 sides are not parallel because if you were to continue to draw this line, okay, they would eventually meet. This means that they are not parallel lines. These parallel lines here, if they continued on forever and ever, they would never cross paths. So, a trapezoid, the definition of a trapezoid is exactly one pair of parallel sides, meaning it cannot have 2, 3, whatever. The parallelogram is 2 pairs of congruent sides and 2 pairs of parallel sides. So what this means is that it has 2 pairs of congruent sides. So looking at here, we know that the 2 sides along the top and the bottom are parallel, and then congruent, and the other 2 are congruent as well. And also 2 pairs of parallel sides. So you'll notice that these 2 sides went on forever. They would never cross, making them parallel. If you take a look also in this direction, whoops, that's a bad example. Okay, and my drawing is of course a little rough, these 2 lines traveled forever, they would also not cross. So a parallelogram definition would be 2 pairs of congruent sides and 2 pairs of parallel sides. Now keep in mind that the images shown here are what you normally see when you talk about a trapezoid or parallelogram. Keep in mind that you may see something that might not look similar to this, but may have the same stipulations as the parallelogram, trapezoid, or whatever the quadrilateral might be. This one is a rectangle. Rectangle has 2 pairs of congruent sides, so much like the parallelogram, and 4 right angles. This is what makes it different from a parallelogram. A rhombus has 4 congruent sides, so instead of pairs, this means all sides are congruent, and 2 pairs of congruent angles, meaning that our angles here are congruent and our angles here are congruent. It's a very small figure, so that's hard to see. Finally, we have a square, which is 4 congruent sides and 4 right angles. So each of our sides is congruent. They have the same length, and every angle in a square is a right angle. You may have realized at this point that some of these may fall into different categories. We're going to talk about these later. For example, if we take a look at a square with 4 congruent sides and 4 right angles. All right, sorry about that. So for example, a square is actually a very special kind of rectangle. It is one where all the sides have the same length. But here you'll also notice, even though they all have the same length, they still have 2 pairs of congruent sides. Really, they're all congruent, but it still fits under the rectangle. So in some of these cases, and you'll see in our examples, a shape can be more than one type of quadrilateral. So just an example to think about, and one that is a common misconception, is that a square is a special type of rectangle. However, a rectangle is not a square or a rectangle is not always a square, because a rectangle has 2 pairs of congruent sides and 4 right angles, but for it to be a square, it must have 4 pairs of congruent sides. So just keep this in mind as we're going along. We'll do a couple examples like this, but this is a common misconception, that a square is actually a special type of rectangle. Also make sure to remember that all of these are quadrilaterals. Okay, here's our first example. Classify each figure in as many ways as possible. So when first looking, we can tell that this has 4 congruent sides. This is a square. Okay, but looking back at our chart and each of these, we want to make sure that we can cover all quadrilaterals that we've talked about so far. So we know it's a quadrilateral, but we're going to focus on what type of quadrilateral it is. So we know it's a square because it has 4 congruent sides and 4 right angles. If it's a square, it's also a very special type of rectangle. A trapezoid has exactly 1 pair of parallel sides. If we look here, these two will go on forever and never cross, and these two will go on forever and never cross. So it has more than one, so it is not a trapezoid. A parallelogram has 2 pairs of congruent sides, which we know we have, and also 2 pairs of parallel sides. So this square is also a parallelogram. Taking a look again, we know a rectangle, we got that one. Rhombus, 4 congruent sides and 2 pairs of congruent angles. Well, we know that all 4 sides are congruent because we've labeled it as a square, and 2 pairs of congruent angles. That's right, we have 2 right angles here and 2 right angles here. They're all the same, so that counts and also as a rhombus. So, as you can see, one figure can count for many different types of quadrilaterals. Okay, you might also see it asking you to label or find something in word form. So for example, name a quadrilateral that has 2 pairs of congruent angles and 4 congruent sides. So this one, you would have to either look back at our definitions and find that this one we know is going to be a rhombus, or you can draw some examples to try to help you figure it out if you were having trouble remembering what the definitions were. So if I'm thinking 2 pairs of congruent angles, I might be thinking about, say something like this, where I have these 2 to be congruent and these 2 to be congruent, and 4 congruent sides. So I might have to draw something a little bit because that does not look like all sides are congruent. That looks a little better. And these would be equivalent, and these would be equivalent. So this would be my shape, and then I could try to identify it that way. So if I'm looking at this, it's going to be a rhombus, specifically 2 pairs congruent angles, 4 congruent sides. But it says name a quadrilateral, so let's see if anything else can fall under that. For a trapezoid, exactly 1 pair of parallel sides. In this case, we would have 2. For a parallelogram, 2 pairs of congruent sides, which we have, and 2 pairs of parallel sides. Oops, that was not supposed to happen. Okay, so taking away my angle measures, what I did with this rhombus for this one, just made it look like this. So these 2 would be parallel and these 2 would be parallel, so this would also be a parallelogram. Okay, we can also look and see if it is rectangle, 2 pairs of congruent sides and 4 right angles. In this case, my rhombus is, in mine, my rhombus is tilted a little bit here, so in that case it is not going to be considered a rectangle, and then a square must have 4 right angles. Now in this one it says 2 pairs of congruent angles and 4 congruent sides, so it really could also be a square. And technically it could also be a rectangle. So any of these answers would fit for this. However, if you look specifically at our definitions, a rhombus is the exact definition of this. However, many of these can fit. All right, which is supposed to be of? Which of the following cannot be a parallelogram? So thinking back to our definitions, a parallelogram is 2 pairs of congruent sides and 2 pairs of parallel sides. So if we take a look at these, we're thinking a square. Okay, if we think about a square, it will have 2 pairs of parallel sides here and here. Okay, and it would also have 2 pairs of congruent sides. Sorry. Okay, so that one would fit. Same thing goes for a rectangle. If we think about a pentagon, okay, so if we're focusing on quadrilaterals, a pentagon is not a quadrilateral because it's not a 4-sided figure. And also, if we think about our trapezoid, trapezoid has exactly one pair of parallel sides, and a parallelogram has two pairs of parallel sides. So a trapezoid will also cannot be a parallelogram. Now pause the video and try these 3 questions on your own. Okay, taking a look at number 1, classify this figure in as many ways as possible. So if we're taking a look, we know that it's a quadrilateral because it's a 4-sided figure. Trapezoid has exactly one pair of parallel lines, that's right here. If these two were to go on forever, they would eventually cross, so those are not parallel. So we know that this is a trapezoid. Okay. Parallelogram, 2 pairs of congruent sides, that's possible, but 2 pairs of parallel sides, that's not going to work because a trapezoid has exactly one pair of parallel sides. Rectangle, 4 right angles, tell right there it's not going to. Rhombus, 4 congruent sides and 2 pairs of congruent angles. We do not have 4 congruent sides in this case. We may have our 2 congruent sides there, however the other 2 are not. And a square, 4 congruent sides and 4 right angles. So this is only classified as a trapezoid. Name a quadrilateral that has exactly one pair of parallel sides. Look at that again. We know that's a trapezoid. Okay? And suppose a triangle has 3 equal sides. Which of the following can you conclude? If all of the sides are equal measured, it must be an equilateral triangle.